Welcome to the first video in section 7.4. So what we've been doing this section is working with rational expressions. You've learned how to simplify them. Last section you also learned how to multiply and divide rational expressions. In this section you are going to learn how to add and subtract rational expressions. So just to first start out, I want to emphasize that adding and subtracting rational expressions is no different from adding and subtracting fractions. So you've been adding and subtracting fractions for years now. You probably learned this in middle school or even elementary school. So a little reminder on what we have to do with adding and subtracting fractions. So this is from your journal. This is on page 207 in your journal. Now, remember, when you are adding or subtracting with fractions, what you need to do is make sure that you have like denominators. Now, what that means, if you've got an expression like this, a over c plus b over c, and just to make it a little more real, let's say we've got 2 over 3 plus 1 over 3. So remember, c is just our number on the bottom, and a and b are just our numbers on top. So if you're adding 2 over 3 plus 1 over 3, that is equal to a plus b over c. Remember, when you're adding or subtracting denominators, when you have like denominators, you don't add those together. Those stay the same. If you have 2/3 of something plus 1/3 of something, you have still 2 plus 1 gives you 3. You have 3/3 of something, which would be the whole. Remember, 2/3 plus 1/3 does not give you 3/6. That your denominator stays the same, and you have 2 plus 1 of those. Now, just the same, if you had 2/3, this is my 2 up here, it's not very, it's pretty, there, 2/3 minus 1/3 of something. Same thing, your denominator stays the same, your denominator stays the same, and you have 1. You are subtracting the numbers on top, but your denominator stays the same. So let me go ahead and zoom out of this. Let me get, sorry, I'm not sure, zoom out. There we go. So you've got, again, when you have like denominators, they stay the same. So in both of these examples, our denominators were already like. Now, in this bottom one, we are going to be doing an example where we have unlike denominators. So our fractions already have different denominators. Let's do an example of that. Let's say we have 2/3 of something. Let me get this back to a larger. Let's say we have 2/3 of something, and we want to add that to 1/4 of something. Now, what we have to do here is we have to go ahead and we can take our denominators and we have to make those into like denominators. So in this case, our a and c values are 2 and 3, and our b and d values are 1 over 4. So what we have to do here is we have to cross multiply our denominators with the opposite numerators to get this to be like denominators. So in this case, we need to take our second denominator and multiply it by our first. So what we're doing here is we are multiplying our entire fraction by 4 over 4. So we get 2 over 4 times 3 over 4. And we have to do the same thing for our second fraction. So this is going to be plus. Now we're taking our second, and we have 1 over 4. Sorry, that's a 4 right here. And we are multiplying it by 3 over 3. So multiplying it by our second. Now look what we've done here, is we've taken our first fraction, which is 2/3, we're multiplying it by 4/4. Now we're taking our second fraction, which is 1/4, and we're multiplying it by 3/3, because that's our first denominator. When we do that, we're going to end up with like denominators. So then this ends up being 8/12 plus 3/12. 3/12. And when we go ahead and combine those, now we have like denominators. This is going to give us 11/12. So an extra step here. What we have to do in this step right here is we are turning our fractions into like denominators. Now you're going to see that we can get like denominators sometimes with a few extra steps. We don't always have to multiply by whatever our second fraction's denominator is. So sometimes by combining and canceling some terms, we don't always have to do this step of multiplying our denominators together. But if you do have to do this, remember that we also have to multiply our numerators by whatever you multiplied the denominator by. Okay, so that's just a little refresher on how we combine fractions. Now, to do this first example, what we're going to do is we're just going to go ahead and combine these fractions. Now, 7/4x plus 3/4x. We first look and see if our denominators are the same. In this they are. So we've got 7/4x plus 3/4x. You have to remember, up to this point we've just worked with fractions that have coefficients, single numbers as our denominators whenever you've added or subtracted them. In this section we're going to be adding in some variables, even some polynomials. But you have to make sure your rules stay the same. So when we go ahead and combine these, this is going to be, our result is going to be over 4x, since these are the same, and all we're going to do is add our numerators together. So we go ahead, we're going to add our numerators, so 7 plus 3 over 4x, and on the top we're just going to simplify our like terms, and we end up with 10/4x. That's what we get. Now, we can simplify this a little bit. We can take a 2 out of both our numerator and denominator, and we would end up with our simplified result. We get 5/2x. You always have to make sure when you're working with fractions, when you get your result, you always have to make sure you simplify, factor out any common terms, and simplify those by canceling them out. That's important because if you forget to do that, you might lose a point on a test, because all of your answers need to be in simplified form. Now, for our second example, you'll see here what's different is that you've got multiple terms in your denominator. Now remember, just like we've been doing when you are multiplying or dividing, when you're working with polynomial, either numerators or denominators, you always have to remember that when you have a plus or minus sign, then your expressions are the same thing as being held together in parentheses. So this x plus 6, these are combined in parentheses. Now that's important to remember. If you're canceling things out, you cannot cancel these x's out right here because this x is inside of these parentheses. So when you look at your denominators, you have to look at both terms as a whole. So your denominator here is x plus 6, that's your single denominator, and your denominator on the second one is x plus 6. So right here you do have like denominators. So your first step is going to be to subtract your numerators. So you combine these, you put them together under the same denominator, and you subtract your numerators. So we have 2x minus 5 here. Now we look to see, can we combine these at all? Are there any like terms or any things that we can simplify? In this case, 2x minus 5 is your simplified form. So you don't have anything you can factor out, and that's fine. You're not always going to be able to combine like terms or simplify, and that's just fine. This here is going to be your final answer. So you would leave it just like this. Okay, so now what I want you guys to do is, for the first question, I want you to do both A and B here, and I want you to write it in the answer box that's going to come up. So make sure you write both questions, A and B, in the same answer box. So your answer for A, make sure you label it A. Your answer for B, make sure you label it B. So that's the first question. Go ahead and write that in the box that comes up. Now, I want you to continue on right here to check your answers on working with some expressions that are a little different. What I want you guys to do is I want you to look at number 2 right here. If we look at 2 over 3x squared plus 1 over 3x squared, I want you guys to look at this right here and also write down your answer in the question box. So question number 2, this is what you're answering right here. So you're answering 2 over 3x squared plus 1 over 3x squared. Go ahead and answer that in the answer box that pops up. Okay, now that you've answered number 2 in the question box, I want to do one more example for you guys. If you look at this first one, we haven't done a subtraction problem yet. Now, you'll see that right here, your denominators are the same. You've got 12x. So in order to do 8 over 12x minus 5 over 12x, what you're going to do is you have a like denominator, so you're going to write your denominator at the bottom, and you're going to write your numerator here, 8 minus 5. Now this one's very simple. You're going to go ahead and combine this. 8 minus 5 is 3, and that's going to be over your denominator, 12x. Now this one here can simplify. Your 3 can go down to 1, and 12 divided by 3 is 4. So your simplified answer would be 1 over 4x. So that would be your solution right here. So 1 over 4x. Remember, it's always important to make sure that you're simplifying everything. So for your final answer right here, the final question, I want you to go ahead and answer numbers 3 and 4 inside the question box that comes up. So 3 and 4 in the question box. Okay, make sure you simplify and write both answers, so number 3 and 4, inside of the question box that pops up.